More questions on gas laws. The first question is, if 300 milliliter of a gas at 27 degrees Celsius is cooled to 7 degrees Celsius at constant pressure, its final volume will be. Four options are given and we have to find out the correct answer. Volume as given is 135 milliliter, 540 milliliter, 350 milliliter, and 280 milliliter. Now, definitely, therefore, this relates to our concepts about Boyle's law and Charles' law. Now, here we the pressure is constant. The pressure is constant. Therefore, we need to perform certain calculations relating to a gas law. We know that P1 V1 upon T1 is equal to P2 V2 upon T2. But here, since the pressure is constant, we put up the same values and therefore they cancel out. And finally, the equation is V1 upon T1 is equal to V2 upon T2. And when you substitute the values given here, 300 milliliter and the temperature 27 degrees Celsius, which has to be converted to Kelvin by adding 273 to it. And 273.15 is the correct value. You may use 273 also. And then we find that this becomes 300. And V2 is the volume which we need to calculate here, final volume, and 280 is the temperature which is obtained when 7 degrees Celsius is converted into Kelvin. And when we substitute the values, we get the volume equal to 280 milliliter. And that's why we safely can infer that option D is correct in this case. Next question. The question is very straightforward and it states that Boyle's law is applicable in isochoric process, isobaric process, isothermal process, and adiabatic process. We know what are these different processes. And so far as Boyle's law is concerned, it relates to the theory that when the temperature is constant, that is, it is isothermal process. So the correct option is C, isothermal process. Isochoric and isobaric, even adiabatic, are not applicable over here. Now, here is the explanation. Boyle's law states that for the given mass of an ideal gas at constant temperature, the product of the pressure and volume remains constant. That means if pressure of the gas is increased, its volume will decrease proportionally and vice versa. So, in isothermal process is one where the temperature remains constant. Boyle's law is therefore isothermal process. Next question comes over here. As the temperature increases, the average kinetic energy of the gas molecule also increases with increase in temperature at constant volume and pressure. So here the correct answer is option A, increases. And that's the right answer. And suitable application explanation is provided here. Pressure increases when the temperature increases at constant volume. And this is explained by Gay-Lussac's law of gaseous volume. Pressure is directly proportional to the absolute temperature when the volume is held constant. As the temperature increases, the kinetic energy of the gas molecule also becomes more, causing them to collide with container walls more frequently and greater force. Thus, the pressure will increase. So, option A is correct. Next question is very straightforward question, and a plot of volume versus temperature is a straight line passing through the origin. The plots of different values of pressures are shown in figure given below, and here is the figure where temperature is plotted in Kelvin in x-axis, whereas the volume in milliliter is represented in y-axis, and different pressures, the straight line is obtained in when the plot is plotted volume against temperature with different pressures P1, P2, P3, and P4. And in each case, we find that the lines, when extended, contact or pass through the origin, that is zero. So here, the correct order of the pressure is in temperature Kelvin A, B, C, and D. These four options are given, and which will be the correct answer we have to find out. Accordingly, we find that option C is correct in this case. That is, P1 is lesser than P2, is lesser than P3, and is lesser than P4. That means P4 has got the highest uh, pressure. So the explanation for this is represented here. And the explanation is that when a plot of the volume versus temperature for a gas is constant pressure is a straight line passing through the origin. This is consistent with Charles' law, which states that the volume of a gas is directly proportional to its absolute temperature at constant pressure. Absolute temperature means the temperature in Kelvin. In this case, as we have noted that different values of the pressure are shown, this implies that the graph represents a series of lines at different pressures where each line is a straight line passing through the origin. The order of pressure is P1 lesser than P2, lesser than P3, lesser than P4. Well, these are the lines represented with different pressures. And what is very important and we have to note down is that the slope values decreases as we go from line P1 to P4. We find in the figure, since pressure is inversely proportional to the volume at constant temperature, as pressure increases and volume decreases. That means when pressure is increased, volume is decreased. So the line at P1 would have the greatest slope, followed by P1, P3, and P4. This is more important and has to be noted carefully. Okay, simple question is here. Ideal gases, 3 points are given. Ideal gases have no volume. Second, particles with no attractive forces between them. Third, have no mass. We have to choose which is the correct characteristic of ideal gas in terms of options provided here as A, B, C, D. And here we find that option B, that is second one, is correct. 2 only. Another question is here. Very simple question. Kinetic and molecular theory states that the average kinetic energy of a molecule of a gas is directly proportional to the temperature of the gas in Kelvin. B. Collision between gas molecules are inelastic. C. Gas particles occupy discrete areas of space. D. All gas molecules have the same kinetic energy at the same temperature. And obviously, as we find here, option A is correct. The average kinetic energy of a molecule of a gas is directly proportional to the temperature of the gas in Kelvin. Another question. The question is, which of the following best explains the difference in ideal behavior between nitrogen and fluoromethane gas? And if you look at the four options provided here, we find that option B is correct. Nitrogen gas is more ideal because its particles or the molecules are smaller and form weaker intermolecular interactions. So that's the correct answers. All other options are not applicable here and are incorrect. Okay, thank you. Please do subscribe to our channel.